All right, welcome new recruits. Get ready for a special math detective mission. We're going to crack some of the toughest looking cases you've ever seen, all with just one secret tool.
Okay, let's dive right in. Our first case file, whoa, this thing looks like a real monster. I mean, this is the kind of problem that would make a calculator just give up and start sweating. So look at this. How in the world are we supposed to figure this out without like a supercomputer? This seems totally impossible, right? But here's the thing. Every single mystery has a clue, and our job is to find it.
You know, the secret to solving mysteries like this, it isn't about getting a bigger calculator. Nope. It's a secret code hidden deep inside the numbers themselves, a repeating pattern that holds the key to everything.
Think about it. Numbers do the exact same thing, especially when you start messing with powers. They fall into these really predictable repeating cycles, and that is something we can totally use to our advantage.
So this whole idea of repeating patterns has a fancy name, periodicity. And let me tell you, this is going to be the key to cracking every single one of our cases today. It's our #1 top secret detective tool.
Okay, let's start looking for clues. The question only asks for the last digit. That's a huge hint. The last digit of 13 is 3. And guess what? The last digit of 93 is also 3. So that means the pattern for powers of 3 is our first major clue. We're on the trail.
Okay, now let's look closely at the last digits, the unit digits. We get 3, then 9, then 7, then 1, and then, look, it starts all over again with 3. That's it. We've found the cycle.
And there it is. We've got it. Our secret code is a 4-digit pattern, 3971. Now, we're ready to solve this thing.
Okay, we have our code. Let's get to work and apply it to finally crack the mystery of 13 to the 19th plus 93 to the 99th.
Our detective plan is super simple. Just 3 steps. It all comes down to one thing, the remainder. That little leftover number is going to tell us exactly where to look in our secret code.
Okay, let's tackle the first part. 13 to the power of 19. The power is 19. Our pattern length, our code, is 4 digits long. So, let's do the math.
So, 19 divided by 4, well, that's 4 with 3 left over. The remainder is 3. And that remainder, that is our golden clue. It tells us we need to look at the third number in our pattern.
Let's see, our code is 3971. The third number is 7. Yes, so the last digit of 13 to the 19th is 7. Awesome, we're already halfway there.
All right, now for the second part, 93 to the power of 99. We're going to do the exact same thing. Take that big power, 99, and divide it by our pattern length, which is still 4. And what do you know? The remainder is 3 again. 99 divided by 4 is 24 with 3 left over. That means we look at the third spot in our pattern one more time.
So the final digit of 93 to the 99th is also 7. So our whole giant scary problem is now just, what's the last digit of 7 plus 7? That's it.
Well, 7 plus 7 is 14, so the final digit is 4. And just like that, we solved it. An impossible problem cracked. Case closed.
Okay, detectives, don't rest yet. Next up, we've got a case from the official files of the 1993 American Mathematics Competition. Yeah, this one's a real head-scratcher.
So, what is the sum of all the digits in the answer to 10 to the power of 93 minus 93? Again, this number is just way too big for any normal calculator. But you know our #1 detective rule. When in doubt, look for a pattern. Let's test out some smaller versions of this problem and see what clues we can find.
Whoa, okay, look at that. A pattern jumps out almost immediately. Every single time, the answer is a whole bunch of 9s followed by a 0 and a 7. That is a fantastic clue.
Okay, so here's how we crack this vanishing 9s case. The power is 93. And if you look at the pattern, the number of 9s is always the power minus 2. So for our problem, that's 93 minus 2, which means we have 91 9s. The answer is literally 91 9s followed by 07. Now we just have to add up all those digits. That's 91 times 9 plus 0 plus 7.
And that final sum is 826. See? You've totally got this. Case closed.
All right, detectives, one last case to solve. This one is a little different. It's a remainder riddle. But guess what? The secret to solving it is exactly the same. Find the pattern.
So, what is the remainder when 1,999 to the power of 2,000 is divided by 5? Okay, let's crack this thing. The biggest clue here is that when you're dividing by 5, the only thing that matters is the last digit of the number.
The last digit of 1999 is 9. So this whole gigantic problem really just boils down to the number 9. But wait, it gets simpler. What's the remainder when you divide 9 by 5? It's 4. So this entire case is really about finding the remainder for powers of 4. How cool is that?
So let's find the pattern for the remainders of powers of 4. Look, the remainder is 4, then 1, then 4, then 1 again. It's a super simple two-step cycle that just repeats over and over.
Our power is 2,000. And 2,000 is an even number, right? So we just need to look at our pattern. For all the odd powers, the remainder is 4. For all the even powers, the remainder is 1. Since 2,000 is even, the remainder has to be 1. And that's it. Mission accomplished, detectives. Case closed. You solved every single one.
Okay, you have officially leveled up your math skills. Let's do a quick review of the awesome tools you added to your detective toolkit today.
Remember these things. Always look for patterns and cycles because they're everywhere. The last digit is usually your biggest clue. Division and remainders are your secret weapons. And always break down giant problems into small, solvable steps. Really, the main takeaway is that the biggest, scariest-looking math problems usually have a simple pattern just hiding inside, waiting for you to find it.
So, what other number patterns are hiding out there in plain sight, just waiting for a detective like you to discover them? Now it's your turn. Keep your eyes open. You never know what mysteries you're going to solve next.